Hi, thank you for having me here today. Apologies, I couldn't be in person. I've been traveling all week and I needed to be at home today, so I do apologize I wasn't able to come down in person and see all your lovely faces. But today I wanted to talk a little bit about kind of countdown to crisis. How is it that we can start making smart decisions in these high stakes? And primarily what I actually like to talk about, you may have guessed from my title, I come from a cybersecurity background. The piece that we're actually going to talk about today is ransomware. Now, before we do jump into talking about ransomware, I wanted to just first start talking about software. We use software every day in our lives in ways that we often think about. Now, this could be Office, Adobe Reader, Google Chrome, Dropbox, etc. But we are using software in different ways in our lives when we are thinking. But software also impacts us in ways that we do not often realize. As we have become a more technologically integrated world, community is probably the term I would want to use there, we have realized that software is impacting us more and more. So for example, we have things like operating theatres. They are ran by software at the end of the day. Airlines, flying us here, there, and everywhere. It's essentially a baked bean tin with loads of people inside, with some big turbines on the side, which are all managed through software. We then have over on the left, we've got ambulances. My favourite implementation of software of any kind. Essentially, an ambulance, when it hits, when it comes to a stoplight, a traffic light, red light, it will actually try to turn that light green as quickly as possible to get to its destination quickly. Now that, in itself, is software. And then obviously rockets, hugely combustible things that are basically just glorified explosives, all managing to hopefully not blow up, all based on software. Software impacts us in ways that we do not think in our lives. Like, for example, I bought a new car actually in February now. And so I bought a BMW, and on it the wing mirrors you can fold in when you press a button or you hold down the lock key for like 5 seconds or something. Awesome, because it's a great way to be able to look out of your house and double check that the car's locked. You can see the wing mirrors are folded in. The problem is, when you just press the lock button once to lock the car, it doesn't lock automatically. Now, I found out what you can do is download an application called Bimmercode on your phone, plug something in to your car, and you can edit the code there. There he is. I do apologise for that. So when we think about software, we do not think about, how is the software going to integrate in with my car? We don't think about how the software changes our lives and the routes that we take to work. Software impacts us in ways that we do not always think about. Now the thing with that is, with software, the possibilities of it are truly endless. Software is this incredible thing where we are limited by what we can think of in our minds. But there is something that's worth noting here, because when there is good, there is often bad. Yin and yang, all that kind of good stuff in the world. And at the end of the day, if we think about what is software? Well, software is essentially a service that gets provided to a user or to an end user or to something. So by definition, we can say that malware is just software. The key difference here is basically, is it good or bad? Good code or bad code. And realistically, what is the difference between that? Good code is Google Chrome. Well, I don't know if you'd say Google Chrome's good code, but you could argue that certain applications are good code. But then there's bad code as well: ransomware infections, data breaches, malicious malware attacks, that kind of thing. So an interesting piece for anyone who's into cybersecurity. There are over actually 100,000 new pieces of malware that are detected every single day. And there are over 1 billion malware programs out there in the wild right now. Every 11 seconds, a business is hit with ransomware. So truly, when we start to think that the possibilities of software are truly endless, well, the malicious possibilities are also truly endless. They are one and the same. They are integrated in with each other. if we think back to early malware, you have the I love you virus. That was a pretty key one. Essentially, for those of you who don't know, the I love you virus would pop up on your computer and then spam all of your contacts with I love you. That was it. So it wasn't necessarily a malicious program. It was more of an annoyance. It was slightly annoying there. You then had things like the Bill Gates virus. It popped up on Windows and said mean things about Bill Gates because they had a vulnerability inside of Windows that wasn't fixed yet. But what we have seen is that these malicious attacks 30 years ago, 20 years ago, 10 years ago, they were kind of for a laugh. They weren't realistically there to wreak a ton of havoc. And this is where we have seen a huge shift over the last few years towards ransomware. Now, I'd like to start off when we talk about ransomware with the first piece of ransomware that was ever released, and that is right here. It is the AIDS Trojan. So, really interesting story with this, actually. Essentially, it was on a floppy disk sent out to AIDS researchers, which is where it gets its name from here. And then the AIDS researchers would plug this floppy disk into their machine, and they would actually go ahead and it would overwrite all of the data after the 90th boot cycle. Now, this was all the way back in 1989. When we think of ransomware, we think, what, 5 years ago, 10 years ago at most? 2012, 2013, CryptoLocker v3. But what we have right here is the earliest version as to what we see as ransomware. Now, the problem back then was cryptocurrency didn't exist. So, how did they get paid? Well, the author, a guy called Joseph Popp, basically said you need to pay $189 to a PO box based out of Panama. So, yeah, he got caught pretty quickly. But moving on from there, to be honest, ransomware kind of died for a good few years, I would say there, until we started to see these kind of high-profile attacks. Again, I mentioned earlier about CryptoLocker v3 2012, 2013. This is one that everyone will have heard of, I would expect, in the room. The WannaCry attack, it was all over the news in May of 2017. WannaCry was spreading across networks and infecting huge amounts of data. And the thing is, as well, we always think, especially in the UK, that WannaCry was quite singular to us. It infected over 200,000 machines globally. So WannaCry was a pretty dangerous attack. Where it's really interesting, though, with WannaCry, I don't often talk about this, it wasn't a very successful attack, actually. It infected a lot of machines, but the payout wasn't very high, especially for the amount of machines that it infected. We're not talking multi-millionaires who were made out of this. So it was actually quite a low success rate for infections. Part of that is because the kill switch for WannaCry was found quite early, but also it was quite easy to find. So there were concerns at the time. I'd need to actually read up about it again to see if it still is a concern. But there were concerns that kind of a stepping stone. They were testing out a new piece of malware before they released a really, really bad one. So very, very interesting here with WannaCry. We then bring it forwards to today. This was actually May 2021. The Irish Health Service was attacked as well. Now, whereas with WannaCry, we were hit the NHS was hit in the UK, and it crippled us, but it didn't take everything down. We still had surgeries that were running. We still had doctors, places that were still able to do doctoring and all that kind of stuff. The Irish Health Service, literally, they had to take down both national and local systems. Long story short, there were a ton of really cool tech that went behind this, but the group behind it, called Conti, used ransomware to deploy, used Cobalt Strike beacons to deploy ransomware. They used WMIC to be able to delete shadow copies, so you didn't have ways to be able to get back up and running from a backup piece, and then PowerShell scripts as well at numerous pieces throughout this. Now, what this is really, really scary is they actually had to resort to using pen and paper. We're talking a National Health Service had to resort to using pen and paper in the midst of the COVID pandemic when they were starting to do COVID vaccinations. Absolutely insane. So we spoke about all these kind of high-profile attacks, but I like to make it very clear. We're not talking just high-profile that's being hit. This is a lovely lady called Sharon McKeel. She runs a dog charity based out of Ottawa, Canada. And in 2016, she essentially woke up and found that her machine had been infected with ransomware. Now, the hackers were requesting that she went ahead and paid $1,500 to get pretty much about 15 years worth of work And being the absolute legend that she is, she said, "I'm not paying this. You know, this is money for the charity. I'm happy to lose it." Now, you know, the moral of the story is, at the end of the day, an anonymous donation came through, which allowed her to pay the fine, which was great, wonderful. But what we're trying to stress here is that everyone has a likelihood of being hit. I mean, we have a huge amount of attacks that happened last year. We look at endpoint breaches with Kaseya and SolarWinds. I touch on that in a little bit later. Merseyrail, the director, the technical director at Merseyrail, had his email hacked, and then by the ransomware hacker, and they sent an email around to everyone in Merseyrail and to news organizations telling them that they had been hit with ransomware. And there's a ton more that are really high-profile attacks. But what I'd like to make very clear is that it does not matter the size of your business. There is no one set vertical they're going for. There's no one set employee size they're going for. We see about 70%, 65% of attacks are for sub 1,000 employees. But from there, I mean, we're still seeing 35, 40% of attacks upwards from there, going from 1,000 who... I'd say 10,000 is realistically where it kind of caps out. When you start going higher than that, you do still have those attacks, but they're much less common because they generally have a higher security solution in place. And from what we have found here is that actually 77% of the ransomware attacks involve the threat to now leak data. Threat actors now know that you guys have more than likely all got backup solutions of some kind. And they know that you can get back up and running using those backup solutions, which is great. But the problem here is that they'll now just threaten to leak your data to your customers, to the dark web for purchase, or to even your competitors. Because they realize that leaking your data is going to be the #1 way to be able to make you pay. Again, they are not targeting a specific vertical. They are going after managed service providers. They are going after small, medium business. They are going after enterprise. They are going after literally everyone. Now, how is it, though, that they're delivering this malware? Well, they're going ahead and they're utilizing solutions like SolarWinds and Kaseya. These are management tools that IT providers or even your own internal IT teams are utilizing to manage their IT infrastructure. You know, these are ways to be able to deploy software onto machines. These are ways to be able to get access to machines pretty easily. They're using tools like rubber duckies. I really like these. I'll show it on my camera. So this right here, that right there is a rubber ducky. It looks just like a USB. I actually have a normal rubber ducky as well, but it looks just like a USB. But when you go ahead and plug this into a machine, it's going to act as a keyboard and then run whatever line of code I have on this. These are terrifying. Because let's be realistic, guys. If I had a USB like this, and I dropped this in a car park with payroll written down the side of it, how many of your users are not going to plug this in? Now, I have lines of code, for example, that will use PowerShell to take a copy of your data and upload it to Google Drive. And I'm not aware of a security solution outside of what we offer here, but that's not what I'm trying to say, that can actually stop that. So these are pretty terrifying here. And then vulnerabilities. Vulnerabilities are a huge, huge threat that we have been seeing growing and growing more over the last few years. I mean, last year alone, there were almost 28,000 individual CVEs that were released. So common vulnerabilities, I believe is what it stands for. A couple of the really key ones, Print Nightmare, absolutely terrifying. Allowed you to be able to run remote code execution, allowed you to be able to run privilege escalation on applications by injecting a malicious DLL. It was a very simple process, and what made it worse is it was easily documented on the web so that threat actors could go ahead and implement this on machines they wanted to attack. Log4j, another terrifying vulnerability that was coming out last year. Actually affects over 3 billion devices globally because this is a built-in logging tool inside of Java. And we use Java on most devices that we have. And again, this allowed for remote code execution. There was a great video demonstration of a security analyst called John Hammond on YouTube, utilizing the Log4j exploit to hack a Minecraft server. Like, even Minecraft was vulnerable to this. So, absolutely terrifying. And the threat actors are using things like living off the land. They're using the Lolbas project. So the Lolbas project is essentially a project to be able to, very simply, run Windows solutions to attack Windows solutions. So you can use RunDLL to run remote code straight from the cloud on your local machine. You can use command prompt and PowerShell to steal your data. Really, really cool project. If you Google LOLBAS project, there's a GitHub page on it. Really, really great from an educational standpoint there. So it's literally, I think it's the first, the first piece on there. So definitely check that out. Now, how is it that we can solve this problem? Well, right now we are utilizing AV. We're using heuristics, threat hunting, ransomware detection, and next-gen antivirus. All of these lovely buzzwords that vendors love to use. Myself, working at a vendor, I understand the hypocrisy of me saying that. But you know, it's all of these lovely buzzwords. But being brutally honest, it's straight up not working. Like, we are still having zero-day attacks that are happening. We still have AV tools that aren't picking up ransomware attacks that even we've known about for years. But there are obviously some solutions. And this is where I like to bring up this security triangle here. Here at ThreatLocker, we like to look at things from more of an angled approach, rather than layering solutions on top of other solutions. The problem is, if we currently look at security as a layered security solution, we're putting multiple threat scanning tools, all more than likely picking up the same threats because they're using the same definitions, stacked on top of each other. Now, why am I doing that? It's costing me more money and I'm losing resource on my machine, and it's frankly not giving me any extra protection. So if we're much more strategic with what we can do on our machines and how we can protect ourselves, well, we're going to be much better protected. So let's look at it from an angular perspective. Right down the bottom. Security awareness training, right? So, Doris, don't plug in that USB. Or, you know, Jeff from accounts should not be clicking on those dodgy links, right? It's very simple. It's training our users. Don't do stupid things. The problem is, there is only so much training we can do, because at the end of the day, everyone has a bad day. We may have fallen out with our partner the night before, or the dogs kept us up all night. And we are going to forget things. Sometimes it just happens. It's life. And that is why we have solutions like detection. Essentially, detection allows you to, and this is where we sit generally at the minute. It's AV tools, it's EDRs, MDRs, that kind of stuff. The problem with this, it's great, but what it does is in the name. It detects. It detects that a problem is there. It doesn't solve the problem. It doesn't stop the problem. Now, this is where we need to be looking in controls. And this is actually where zero trust really, really fits in. So what is zero trust? Well, zero trust is the idea that we should only be allowing essentially minimal access to users and applications across our networks. Now, we can actually do this by denying access to any application that's not pre-approved, giving users least privilege, etc. And we're going to touch on that now with essentially 4 key components. The first of which is app whitelisting. It comes under a few names. There's application whitelisting, default deny, deny by default, allow listing. That's the other one. So generally different vendors will call it different things, but long story short, what you are doing is you are saying only these files are allowed to execute, or only these applications can run. That is it. Now, why is that great? Because users can now, well, users can't now install Angry Birds. They can't install TeamViewer. They can't install random bloatware on their machine and then complain that things are running really slow. But it also means that they can't run ransomware, which means that your data isn't going to get infected. Now, once we have gone ahead and chosen what can run, and then everything else gets blocked by default, we then need to look at what can run and how that can be weaponized against us. I spoke about it earlier. Application weaponization, or vulnerabilities, is a huge, huge thing. Log4j vulnerability is a huge way that we've seen threat actors weaponize, Log4j, to be able to access data on machines, run remote code execution, steal information from users. So we need to look at what our applications are doing. Because why does Office, and this is something it can do by default, Office need to access PowerShell, one of the most powerful applications you have on your machine? And then why does PowerShell need to access your files and folders? Because this is how I can do my stealing of your data attack. So what we need to do is we need to look at how our apps are working and then limit what they can do. So one of the default ThreatLocker policies that we apply on our solution is actually blocking PowerShell from accessing any of your data, and we also stop it from accessing the internet. And that means that if a threat actor was to get in your machine and tried to use PowerShell to be able to access the internet, to be able to download ransomware and then run it on your local machine, it's blocked. It can't do that. And obviously, feel free, you don't have to take my word for it. Take the word of this guy here. So the guy on the right, this man with lovely glasses, he is a... Taking a step back, when you are a ransomware attacker, if someone pays, what you generally offer is some technical support to be able to essentially help them in the event that they do go ahead and pay to get their data back. It's kind of extortion and then asking them to thank you afterwards, which is super not cool, obviously. So what's happened here is this person on the left has gone ahead and they've paid, and they've asked the hacker, what can I do to stay protected in the future? And the hacker themselves has actually said, approved to run only the necessary applications. That's it. So if you take anything away from today and you're like, I'm not going to listen to that man on the screen, no. Like, just listen to that one there. They themselves are saying that application whitelisting, deny by default, allow listing, whatever you want to call it, is the best way to protect yourselves. From there, we need to go ahead and we need to minimize the amount of users that have local admin control on our machines. Okay? Ideally, we should have none. But the problem is often we have users who need to be able to run specific applications as an administrator, for example. Okay? Maybe it's one app needs to update every 6 months or so, and it has to be admin right to be able to, or even like really old applications that just need admin access to run. Well, what we can do is remove admin control from users, but allow them to be able to run individual applications as an administrator. Now, there are a few different vendors that are able to offer solutions like this. If you're interested, obviously, we are able to. I would love to have a conversation, but there are multiple of solutions that can do something similar to this, and it's called an elevation control solution. So very, very cool solution, and allows you to be able to remove that local admin piece, making your users more secure. The final piece is actually a two-pronged approach. Storage control. Number one, USB blocking. 59% of people who leave a business take some kind of confidential data with them, and more often than not, that is on USBs. So, we need to have USB blocking in place, but granular USB blocking. Allow USBs to be able to run by the serial number on the USB if you wanted. And then from there, what we then want to go ahead and do is control what applications can access your data. So by default, your backup software, Veeam, should be able to access the backup location, right? Like that makes sense. But why does Office need to access it? Why should PowerShell ever need to access that data? Well, what we can do here is go ahead and lock that down and say that only this folder can be accessed by this one application, or these two applications, for example. By doing this, we can secure our data effectively. One of the first things that ransomware does when it gets on a machine is it looks for any NFS, CIFS, SMB shares, it looks for backup locations, and it looks for OneDrive sync folders, Google Drive sync folders, that kind of stuff. Well, if you have a limit on that folder as to what applications can access the data on that folder, you are able to very clearly and very effectively lock that down and stop ransomware from accessing your data. And by doing all of this, we can effectively change the paradigm of endpoint security. We can change the way that we view endpoint security here. Now, thank you again, guys, for having me. It's been an absolute pleasure. Again, I am very sorry that I wasn't able to make it in person today. Hopefully next year, if you guys will have me back. If you would like to learn a bit more about ThreatLocker, please feel free to ping me an email. It's ben@threatlocker.com. And always feel free to add me on LinkedIn as well. I'm happy to have any conversations. Thank you, guys.
Thank you very much.